All right, let's dive deep into one of the most incredible systems running our entire lives. We're talking about the powerful network that I like to call the body's reproductive command center.
I mean, have you ever really thought about it? What is it that actually flips the switch on for puberty? Or what's the master controller that's dictating fertility, your monthly cycle, and even the changes that come with aging? Well, it turns out it's not just one thing, but this amazing, super coordinated system. So, let's meet the team. The system we're talking about has a bit of a mouthful for a name, the Hypothalamic-Pituitary-Gonadal axis. We just call it the HPG axis for short. And really, it's a team of three glands: the hypothalamus in your brain, the pituitary gland right next to it, and the gonads. That's the ovaries or testes. The amazing part is they all act as one single powerful unit.
So yeah, let's get to know this leadership team a little better. These three glands aren't just neighbors. They are in a constant, dynamic conversation that, basically runs the entire reproductive show for your whole body. When you boil it down, the HPG axis is this one single system that's in charge of development, reproduction, and aging. But its influence, it's huge. It goes way beyond just making babies. It affects major life stages and even talks to our immune system.
So how does this team actually talk to each other? Well, it works kind of like a top-down chain of command in a company, with these little hormonal memos being sent from the very top, the brain, down to the rest of the system.
Let's break it down. Think of the hypothalamus as the CEO of this whole operation. It sends out the main directive, a hormone called GnRH. But it does so in these really carefully timed pulses. Then the pituitary gland, that's like the manager, gets the GnRH memo and, depending on the instructions, sends out two of its own key hormones, LH and FSH. And finally, those hormones travel down to the gonads, the factory floor, and tell the ovaries to make estrogen or the testes to make testosterone. It's just a beautiful, elegant cascade.
But here's the really cool part. The CEO doesn't just yell one command. The real genius is in the rhythm of that GnRH pulse. It's everything. If the hypothalamus sends out pulses faster, it tells the pituitary to make more LH. If it slows the pulse down, it favors making more FSH. This delicate rhythm is how the entire system fine-tunes its instructions for every single part of the reproductive cycle.
But wait, how does the CEO know if the factory floor is actually doing its job right? Well, the HPG axis has this brilliant built-in performance review system. Scientists call them feedback loops.
So there are two main kinds of feedback. The default setting is negative feedback. It works exactly like a thermostat in your house. When your estrogen or testosterone levels get high enough, they send a message back up to the CEO that says, "Hey, we're good down here, you can slow things down." This keeps everything nice and stable. But then, there's positive feedback. This is like a special override switch. Right before ovulation, high estrogen levels do the exact opposite. They tell the hypothalamus to slam on the accelerator, causing a huge hormone surge that's needed to release an egg.
Now, this command center isn't working in a bubble. It's constantly getting updates from all over the body. It needs a key messenger called kisspeptin to even get the whole process started. But it's also listening to hormones like leptin from our fat cells and insulin, which basically give it a green light, signaling, hey, we've got enough energy to reproduce. And on the other hand, ghrelin, the hunger hormone, acts as a red light, telling the axis to cool it when energy is low.
And there's no better example of how all these pieces come together than in what is probably the command center's most complex and famous project, the menstrual cycle. Okay, so when you look at a chart of the hormones involved, it can look, well, pretty complicated, right? With all these signals rising and falling in this precise dance, it might seem a little overwhelming at first, but it's actually a super logical sequence of events. So let's break it down. We can really simplify the whole thing into three main phases. First up, you've got the follicular phase. That's where FSH helps a follicle in the ovary start to grow, and as it gets bigger, it pumps out more and more estrogen. Next up, ovulation. This is the main event, where that high estrogen level flips the switch to positive feedback, causing that massive LH surge that tells the follicle to release the egg. And finally, we enter the luteal phase. The little structure left behind in the ovary starts making progesterone, which is the hormone that gets the uterus ready for a potential pregnancy. Scientists have a really cool word for how the system pulls this off: bistability. All that means is that the axis can exist in two stable states, kind of like a light switch that's either on or off. The system brilliantly flips from its stable negative feedback state to its stable positive feedback state just to drive ovulation, and then it flips right back. It's just a super efficient biological switch. But of course, just like any complex communication network, sometimes the lines can go down.
And when communication in the HPG axis breaks down, it can have some pretty major effects on our health.
So let's look at two common examples. With polycystic ovary syndrome, or PCOS, the GnRH pulse generator, our CEO, it gets less sensitive to that negative feedback. It just keeps pulsing too fast, which creates this constant state of high LH, and that leads to excess androgens. Then you have something like hypothalamic amenorrhea. In this case, the system basically just shuts down. It doesn't even enter its active reproductive state, and that's often because of things like severe stress or not having enough energy, and menstruation just stops completely.
So what kinds of things can cause these disruptions? Well, it's a mix. Chronic stress, overtraining, eating disorders, these all send a signal to the body that it's probably not a great time to reproduce, so the axis gets suppressed. There can be genetic reasons too. And of course, hormonal birth control. That actually works by intentionally suppressing this very axis to stop ovulation from happening.
So why is all of this so important? Because understanding this axis isn't just for science class. It is absolutely crucial for developing effective treatments for infertility, for managing hormonal disorders, and for supporting reproductive health through every single stage of our lives, from puberty all the way through menopause and beyond. It really leaves you with a pretty amazing thought, doesn't it? If this one single axis has so much power over our physical development, our moods, our future, it just makes you wonder, what other incredible secret systems are humming away inside of us, running our lives from behind the scenes? Something to think about. Thanks for tuning in.